Hi everyone, let's start without delay. Let's start Coulomb's law of electrostatics. Okay, so first let's know what is the law. Just a minute. So, according to Coulomb's law, the force of attraction or repulsion between 2 point charges, let's underline this. We will know what do we mean by point charges. Okay. So the force of attraction or repulsion between 2 point charges is directly proportional to the product of the two charges and inversely proportional to the square of distance between the two charges, and the direction of the force is always along the line joining the two charges. Okay, so this is the statement of Coulomb's law. Let's understand this. First, what is this? The force of attraction or repulsion. Always keep in mind attraction happens between opposite charges. Okay. If two charges are of opposite nature, in that case, both the charges attract each other. Okay. But if the two charges are of same nature, means either both are positive or both are negative, in that case repulsion occurs. Okay, so the force of attraction or repulsion in it mathematically so okay, let's take one charge capital Q, another charge small q, separated by some distance which is obviously much greater than their size. That's why we are taking this. Okay, so now the force of attraction, what is given there? The force of attraction or repulsion between two charges is directly proportional to the product of the two charges. Okay, so let's write it directly proportional force. Here both the charges are positive in nature. We will go to that part later. First let's write this statement mathematically. F is directly proportional to capital Q multiplied with small q. Okay, and it is inversely proportional to the square of distance between the two charges. Inversely proportional to the square of distance between the two charges. Okay, if we write it properly, F is equal to K proportionality constant Q by R square. Okay, here this K has some values. K is equal to where K is equal to 1 by 4 pi epsilon naught. Okay, that is equal to 9 into 10 to the power 9. Can you tell me the unit for K? If you can't tell the unit, you cannot find the dimension also, isn't it? So the unit for it, this is, I'm just writing it here. Just do one thing, do cross multiplication, take all the terms. We have to find the unit for K, na? So take all the other terms which are along with K to the other side, to the fourth side. Okay, keep the K alone. So K is equal to F into R square divided by capital Q into small q, cross multiplication. Now the units are of force is Newton, R is what? Distance. So unit for distance is SI unit, meter. So here R square, so meter square divided by charge coulomb, unit for charge is coulomb. So this is coulomb square. Okay, Newton meter square coulomb square. Got it? This is the unit for K. Newton meter square by coulomb square. Okay, erasing this. Now this epsilon naught here is, this also has some value, and this is called permittivity of free space of free space. Okay, so and this quantity. Okay, first let me tell you what is permittivity. Permittivity means it is the ability of a medium to allow electric field through it. Okay, the ability ABLITY. I think I just wrote a little wrong. ability of a medium to allow electric field through it. Okay, so this epsilon naught is called permittivity of free space, means how much electric field can go through a free space. It represents that, and it also has some value, that is 8.85. please remember all those things because we are going to use these things many times, okay, to solve problems. 8.85 into 10 to the power minus 12. Can you tell me its unit? Coulomb square by Newton meter square. Find the unit like that. How just before, just sometimes ago we learned, na, like that you just try to find its unit. Okay, this is the value of epsilon naught. Value of k is 9 into 10 power 9. Value of epsilon naught is 8.85 into 10 to the power minus 12 coulomb square per Newton meter square. Okay, so and there is another thing also. Just remember this epsilon naught, what permittivity, epsilon is equal to, remember this relation, okay, epsilon is equal to epsilon naught into epsilon r. Here epsilon is equal to absolute permittivity, okay, absolute permittivity epsilon naught is permittivity of free space, okay, and epsilon r is relative permittivity, relative permittivity, okay. So from this we can write, and always remember epsilon r is equal to 1 for air, okay, or for free space. Okay, and epsilon r is equal to 1 for air or free space, means for vacuum epsilon r 1, okay, but for other mediums it is more than 1 or maybe less than 1, but it is not 1, like sometimes okay, next one is, okay, so what we learned till now is F medium, F air is equal to, or vacuum is equal to, so we learned F is equal to normal force, F air, or for vacuum is equal to 1 by 4 pi epsilon naught Coulomb's force of attraction will be QQ by R square, okay, for air or vacuum, okay. Now for example, the charges, if the charges will be inside some other medium, okay, like oil or any dielectric medium, okay, so in that case epsilon r will be different, got it. So in that case what we will write, F medium is equal to 1 by 4 pi epsilon naught, as it is you write, after epsilon naught just write epsilon r, okay, because it will be different, not 1, okay, only for air or vacuum it is 1, other things as it is, QQ by R square, got it. Now can you tell me this much represents F air, this let's take F air, okay, so can we write F air divided by epsilon r is F medium. For example, if it is given that two charges capital Q and small q separated by distance r are immersed inside a oil container whose relative permittivity is 2, let's take, okay, in that case find the electrostatic force of attraction, because both are same nature, so it is asked to find the electrostatic force of repulsion. Sorry, if both are same nature, they will repel each other, isn't it? F medium is equal to F air by epsilon naught. Okay, you just write everything as it is, 1 by 4 pi epsilon naught q by r square. After that just divide 2. Okay, got it? Now, or if it's given that the charges are inside some dielectric medium of dielectric constant small k. Okay, that also, in that case you just divide same only, F air divided by small k. Okay, this is dielectric constant, don't confuse with this quantity. Okay, this is different, this is proportionality constant and this is dielectric constant. Got it? Now let's find the force. Okay, by now what we learned, F air is equal to k q by r square. F medium is equal to F air by epsilon r or small k. Okay, and another formula, absolute permittivity is equal to epsilon naught into epsilon r. Okay, and another thing we learned, epsilon r is 1 for